Hey everybody, just want to welcome you to week 6, module 6 for ME111 System Dynamics. Only one assignment this week. We have quiz number 5. This has been posted to Blackboard and will be due on Friday the 9th by 4 p.m. Also a reminder, I have my office hours on Tuesdays and Wednesdays from 9:30 to 10:30 a.m. But if you're not able to make those times, please just reach out to me via email or through chat on Teams and we'll work together to figure out what time works best for both of us. So for Module 6, we're going to take a look at our electrical and electrical mechanical systems. So upon completion of this chapter, there's a couple things that we should be able to do. One, develop models of electrical circuits. This includes application of Kirchhoff's voltage and current laws, application of voltage and current divider rules, use of loop analysis, selection of appropriate state variables, and the use of transformed equations and impedance. We should also be able to obtain circuit models in transfer function, state variable, and block diagram form, apply impedance methods to obtain models of circuits and op-amp systems, apply Newton's laws along with electrical circuit laws and electromagnetic principles to develop models of electrical mechanical systems, including the DC motors and your sensors. We should also be able to assess the performance of motors and amplifiers when used in motion control systems. And last, we'll take a look at MATLAB and Simulink to analyze the models of circuits and electromechanical systems. So as we start Module 6.1, we're going to be taking a look at electrical elements, circuit examples, transfer functions, and impedance. So corresponding to sections of the textbook, this should go 6.1 for electrical systems, 6.2 for our circuit examples, and 6.3 for transfer functions and impedance. The majority of engineering systems now have at least one electrical subsystems. So this may be something as simple as a power supply, a sensor, a motor, a controller, or an acoustic device such as a speaker. So understanding of these electrical systems is going to be essential to understanding the behavior of many systems as a whole. So as we move on to Module 6.2, we're now going to look at operational amplifiers, electric motors, and analysis of motor performance. Corresponding with our textbook, this is going to be 6.4 for our op amps, 6.5 for electrical motors, and 6.6 for the analysis of motor performance. So as we start to look at these op amps, a modern version of a feedback amplifier is this operational amplifier or op amp. This is a voltage amplifier with a very large gain G, greater than 105. So the op amp has a large input impedance, so it draws a negligible current. It also has an integrated circuit chip that contains many transistors, capacitors, and resistors, and has several external terminals. So we can attach two resistors in series and parallel to the op amp as shown in these figures below. So we can see at A here and over B here, circuit diagram does not show all of the op amp's external terminals. So the last section of this module is Module 6.3. This is where we're going to take a look at MATLAB and Simulink. So let's go over first a case study for design of a motion control system, take a look at some sensors and electrical devices, and then look at some MATLAB and Simulink applications. So if we're talking about sensors and electroacoustic devices, we want to consider two common sensors. So two of the sensors we're going to look at specifically are the tachometer for measuring velocity and the accelerometer, which can be used to measure either acceleration or displacement. So we'll get into a little bit more detail with that. In addition, some electroacoustical devices such as microphones and speakers are going to be based on these electromagnetic principles.